Books at Berklee. I'm your host, Judy Panolis, for the library, Berklee College of Music. Today, we're speaking with Dr. Jennifer Beauregard about the new 2021 ebook at our library, The Brilliant Abyss, Exploring the Majestic Hidden Life of the Deep Ocean and the Looming Threat that Imperils It by Helen Scales. Dr. Jennifer Beauregard is Associate Professor of Natural Sciences here at Berklee in the Liberal Arts and Sciences Department. She teaches environmental science, oceanography, and natural disasters. Dr. Beauregard's PhD is in oceanography from the University of Rhode Island. She specializes in marine geology. Her first love is volcanoes on the seafloor, but she loves learning about all aspects of the Earth's oceans. Welcome, Dr. Beauregard, and thanks for speaking with us today.
Oh, it is my pleasure to be here. I am so excited to talk about the oceans and talk about this book.
Well, the first thing that I wanted to ask you is about the title, The Brilliant Abyss. What really actually is an abyss?
Oh, sure. That's a great question. If you look up the definition in a dictionary, it refers to something with great vastness. And I've always loved thinking about something that has great vastness. I think it makes me feel very small, and I really enjoy that feeling of me feeling small in the universe. For the title specifically, she is referring to the Abyssal Plain, which is a specific part of the seafloor. It is really deep and really flat. Typical depths of the Abyssal Plain are going to be somewhere around 4,000 meters, which is roughly about 12,000 feet of water. And they're very, very isolated parts of the ocean. They're way out in the middle of the ocean, but then way down at the very, very bottom as well.
That's right. She talked a little bit about in the beginning of the book, starting with some definitions about sort of the layers of the ocean and the sea. And that was quite interesting, and people didn't really know exactly what those were.
Absolutely.
How did that develop a little bit about the different kinds of layers, and what are we talking about here?
Oh, great question. The different layers typically are related to how much sunlight different parts of the ocean get, as well as what specific kind of creatures live in those different layers or those different depths. One of the things that, again, I love thinking about is when the sunlight hits the surface of the ocean, the sunlight's going to go into the water. I mean, we all know that you can see light if you stick your face in the water, but it doesn't go very deep down. Typically, it reaches a depth of about 150 meters, so 550 feet of water, which sounds really deep, but for the ocean, it's super, super shallow. And that's the only part of the ocean, this pretty thin skin at the surface where there's enough light for photosynthesis to occur. That's pretty much where we thought life ended in the ocean for quite a long period of time. And then we realized, if you drag a net through water that's deeper, you certainly still find creatures at greater depth. And so we had to kind of reassess, and that's where some of the other layers come from. The one that always makes me laugh is the Twilight Zone. There is an official name for it, but truthfully, I can never remember what the official name is because I'm so enchanted by the Twilight Zone. That is roughly from 150 meters down to 1,000 meters down. So like 550 feet down to 3,000 feet. There is 1% of the light that enters into the surface ocean that makes it down to those depths. So you really have to kind of squint to be able to see the light. But once you go beyond that depth of the base of the Twilight Zone, it is completely dark. And that's mostly what the book is about, those completely dark areas of the ocean, which are called the aphotic zone. So no light at all reaches those depths. And that's most of the ocean. So
I know, it was like really incredible to think about. There's not going to be any photosynthesis. There's not going to be any, plants that are creating sugars that way. And total darkness is sort of hard for us to kind of envision that. And yet there's all kinds of life down there that is able to have its energy through other means. And some of those other means are create tremendous variety of life. In the book, the author talks about such a variety of animals and other life forms that are in these distinct locations around the oceans in different places. Could you talk a little bit about that and some of these adaptable life forms, and how are they down there?
I know.
How is that possible?
How is that possible? Yeah, I mean, and truthfully, this is one of the questions that comes up at least once a week in oceanography class. Like, how does something live there? I don't understand. The adaptations are just absolutely incredible. And that's one of the things that I really loved personally reading about in the book, how she talks about, for example, some of the fish that live down in these incredible depths, and they've adapted certain chemicals within their cells that essentially keep them from popping under the immense pressure that's down there, and keep the cell membrane intact. I mean, how does that happen? I love thinking about and reading more about, even in these pitch black depths, the creatures down there have incredibly well developed eyes, so they can detect the flashes of the other creatures or the bioluminescence of the other creatures. I mean, that always just fascinates me, because I remember watching documentaries on animals that live in caves from childhood. And I was always fascinated that a lot of those creatures have evolved so they either have no eyes or their eyes are very insensitive. And this is because they live in total darkness. This is like the opposite. Their environment is total darkness, but because so many of their fellow creatures down there give off light, it doesn't make sense that they would have lost their sight. In fact, they would have developed even more intensely sensitive eyes or vision. I love that. I think that's fascinating.
It's pretty amazing. And also to think that these creatures are creating kind of their own energy through chemical processes.
Yes. Oh, I completely agree. It's so different from what we think about a lot of times when we think about animals, like my dog.
Speaking of which, I mean, there was this interesting tidbit in the book, and apparently it's been known for, I guess close to 30 years or so. It's been proven that whales are descended from the same creature that wolves are descended from, and that there was a wolf ancestor who went back into the ocean from land, and that became the whales. I don't want to, okay. I knew that whales were mammals, and I knew that they had commonalities with the mammals, but I didn't realize that there was a common ancestor. So our dogs are in fact related to whales.
To your whale friends, I
know. Since that their common ancestor is some prehistoric creature from the land, which seems to also speak to this great adaptability and evolution. And one of the things that was fascinating and that's in this book is about the different areas that develop their own life forms just in that area. So there's so many millions of, I guess one point she estimated 10 to 30 million different species, most of which we know what, a few tens of thousands, maybe we've identified a few 20 or 30,000, but it's there's so much more life down there that we have no clue even what it is.
Yes.
And it's just been there and it's just doing its thing, but it's so adaptable to these different places. I mean, does that speak to evolution ongoing and having the ability to have things evolve differently constantly and all the time in so many myriad ways that life can evolve? I mean,
Oh.
that was one of the questions that I had for you.
Oh yeah. Oh, I completely agree. I would definitely say yes. When you have, like you said, these creatures that today, I mean, they're about as different as you can possibly think of. I have a Chihuahua, and if I think about him, whale does not pop into my mind at all. And yet, like you said, they share a common ancestor that we can trace back. I definitely think that the myriad of creatures that you find and the amazing way, like you said, that they've adapted to some very, very specific ecosystems absolutely speaks to evolution is an ongoing process. If something happens to that ecosystem, certain individuals are going to survive those new conditions, certain individuals are not. And that is definitely a self-selecting process, the natural selection process. So I absolutely think that if we had a way to monitor these locations over a long-term basis, so not like 20 years, 40 years, but 500 years or 1,000 years, I definitely think we would see evolution taking place. It's so much slower than our normal thoughts on time that sometimes it can be very difficult to sort of pinpoint it unless you look back at the fossil record and are able to see essentially these large chunks of time going backwards. But there's no reason that it's not doing the same thing as we are moving forwards either.
Well, that was one of the other things that that struck me is the comparison, and she makes a lot of comparisons in the book to things that people may be more familiar with. That these creatures have this very slow timetable. They don't reproduce rapidly like the fish in the sea are known to, you might have millions of eggs or something. But here in the lower depths, these creatures don't do that. And I wasn't necessarily understanding maybe why that was the case, that they had maybe very long lifespans, even hundreds of years for a fish or something.
Which again, that's crazy.
You could have, but such, how does that go hand in hand with not reproducing very frequently? Is it because of the lack of resources, or why would they be so much more long-lived than fish in the ocean that live much less time than that?
Oh, absolutely. And I mean, truthfully, some of the fish near the surface have a really short lifespan in a lot of cases, months to years in some situations. So it really is the opposite end of the spectrum for lifespans. There's a lot of ideas on that. One of them is exactly what you mentioned, that lack of resources. If you don't necessarily have a really consistent food supply, which we don't think a lot of these creatures do, I mean, it's just so deep. As you mentioned earlier, a lot of what we know is based on photosynthesis and near the surface. We think a lot of the calories that come down in their direction are dead bits that are floating down or sinking down from the surface. But that is not necessarily a super, what's the right word? I don't want to say dependable. It's certainly dependable. You've got dead material that's constantly sinking, but within one location in those depths, you may not have a big chunk of food sinking down to the bottom right in front of you. And so lack of access, they have to be able to store energy for really, really long periods of time, since they don't know when their next meal is going to come in front of them. So I think that's definitely part of it. everything is slowed down for them. Their metabolic rate is slowed down, their heart rates are slower, their blood pressure is slower from what we can tell. And so that probably also relates to starting reproduction much later in life for a lot of them. And then when they do have babies or lay eggs, it's not going to be like 1 million at a time. It's going to be a much, much slower amount, because if they had a lot of babies down there, then they'd have a lot of competition for food as well. So those are some of the ideas of why everything is slowed down in the deep sea. But we don't have as much data to use to test those ideas as we do data to work with for fish that are closer to the surface.
Okay. Well, one of the things that the book does, which is very organized, and she
Oh, yes.
brings you along from, I can say, being a person who did not know very much to start with about the oceans, a novice reader, let's put it that way, a novice reader about the oceans, giving an understanding of these different life forms. And there are some very nice photographs that are included in the book as well. And there's all these really odd
Oh, yes.
they're pretty fascinating pictures and things, but why should people care about, I don't know, a bunch of weird worms, let's say, or whatever is down there? How is that affecting us?
Oh, another fantastic question. And I think a lot of us have those questions. You know, it's so remote, it's so deep, it's so far removed from our day-to-day lives. How can it possibly matter that much? I think that as human beings, we have fallen into that mindset a lot in history to our own detriment. And I'll give you an example. We used to very commonly pile all of our garbage onto barges and not put them in landfills, put the garbage on a big flatbed ship, take the ship a certain distance offshore, and then flip the barge upside down and just dump the trash into the ocean.
Yeah.
Completely unsorted, no recycling, no nothing. Medical waste was in there with the regular garbage. And it took us, the mindset on that was, well, this is just a little barge with a tiny bit of garbage in comparison to the size and the vastness of the ocean. And so the ocean can handle it. And it took us an embarrassing a long time to figure out, no, this is not a very good idea, because not only is it affecting the creatures in the ocean, it's affecting us. That trash is coming back up on the beaches. That trash is being eaten by some of the seafood that then we are consuming. And so we are getting the impact of our short-sightedness, let's say. And so when I get this question, and I get this question in class all the time, why should I care about a worm, a worm with frilly edges at the bottom of the ocean?
Yeah.
And my answer is always the same. We don't know why we should care yet. That worm may be playing a vital role. And we don't know. We just don't know enough. And I'll give you another silly example here that somebody once gave me, and I thought, yes. Imagine if you were given a box from IKEA, the furniture company where they give you picture instructions and you put it together to make like a bookcase. But imagine that you were not given the instructions. You were just given the pieces, and somebody said to you, put this together into something, and you don't even know what the something is. The first thing that you should probably do is learn a little bit about each of the parts and then try to learn how they go together. The last thing you should do is pick up one part and say, I don't know what this is. I don't know what it does. And so I'm just going to throw it out. Because that might be the most important part. If you don't know about this, the components, you don't know what the most important part is. And I feel like that about the deep sea. If we don't know what all the parts do, just kind of saying about one, well, I don't really care about that, or why should I care about that? What if it is playing this big role and we just haven't figured out what it is yet? So that's always my sort of cautionary tale.
Yeah. Well, it certainly makes a lot of sense. I mean, one of the issues that she talks about in the book, Helen Scales talks about in the book, is that oceans could be providing, for example, life-saving medicines and we haven't discovered yet, or other things that we could really use. And one of the things they are doing, she mentions, is mining for different kinds of ores and minerals, especially these days, some of these minerals that are used in making electrical components or batteries or things that are becoming even more valuable right now. So there seemed to be kind of a kind of a conflict of two sides of the story, between mining for parts of things that we know we can use that are going to maybe be more environmental here on land, or disturbing these sites of these animals that can't be really replaced because they're so long lived, they don't reproduce, they don't, all the features we talked about before. And it was kind of a conflict of interest on the environment. And I was wondering if, maybe there's something that you could address about that.
Oh, this one's a hard one. I don't know that I have a very satisfying answer at all, because I think you are right. With the state of the way things are right now, we know we're doing damage to the creatures on land, and we know that we are doing damage to the creatures of the shallow parts of the ocean.
Yeah.
We have to assume that we're also already doing damage to the deeper creatures. Helen Scales talks a little bit about this, that it's not just the surface ocean that's warming up as the planet warms up. The deeper ocean is warming up as well.
Yeah, that was pretty scary when it's so deep.
Oh, yes. I mean, again, you think
that's a lot of water to get.
That's a lot. Exactly. And so, I mean, on one hand, we're already damaging those ecosystems. And so would the damage be worse if we just keep going the way we are going, by using fossil fuels and not moving towards alternative energies that require a lot of batteries, just for example? But on the other hand, you are right. I mean, we are absolutely, the mining techniques that we would be using in these deep areas are incredibly destructive to those specific areas, and potentially even further up in the water as well. And I don't know how you balance that. I don't know how you make a decision of, okay, we're going to essentially sacrifice this ecosystem for the benefit of these other ecosystems that are a lot more visible. And I definitely struggle with that one.
I guess the only response to that would be to have a different way of mining it, if you're going to mine it. But I don't know very much about it. I didn't even know about the issue until so I mean, that certainly is something that people can investigate more by reading the book and reading about these kinds of issues. And she brings up many of those kinds of issues that are really at the forefront of where the discussions and the arguments and the debates are today. And it's very informative for people to read those sections in the book, as well as learning sort of the basics about the ocean and these animals and kind of the wonders of it. She's really giving us a short version, the Reader's Digest version of all of these things that are going on about the oceans, and just understanding how complex it is to really get a handle on what's going on in the world today with all of that. Another thing that I thought was I was wondering if you could address, we mentioned about the common ancestor of wolves and whales. And that is this amazing statistic she put out about 95% of the life habitats on our Earth are in the ocean. And 5%, everything that we know as habitat, the good, the bad, and the ugly of land use or whatever in the world, the entire world, is only 5% of
Isn't that
where life exists. And that was kind of a mind-blowing statistic. I mean, she had other kinds of statistics like that. I think one was the Amazon. Imagine the Amazon River dumping into the sea, and it would take 150,000 years of all that water pouring into the sea to fill up some section of the ocean that she was talking about. And just to give you the scale, she tries to give you the scale of this. It's so enormous, it's very hard to get a handle on these comparisons. And I'm wondering, how do we talk to students or environmental students about these environmental issues when there's just so massive? You think of the oceans as just so massive and so vast. We can't possibly seem to run out of space or run out of resources from it or what have you.
Oh, that is also a really, really good question. I think for me, well, as you mentioned at the beginning, I mean, my background is geology and marine geology, studying the seafloor. And one of the challenges that I had in both undergrad and graduate school is you have to sort of learn how to think about size and time, because time, we get really fixated on, I've got this to do today and I've got this to do this week. And, the ocean doesn't operate on those time scales. It operates on time scales that are, maybe seasonal. But in a lot of cases, a lot of these big picture issues are happening over decade timescales or century timescales. And that's hard enough to start to wrap your brain around, besides the whole concept of, just like you said, the vastness. I mean, it's just an unbelievable amount of space and an unbelievable amount of water, let alone all of the creatures that are living in layers that, I mean, we can only see just a tiny, tiny fraction of them. I usually show my students some other statistics to go with some of those numbers, like if you look at how much life there is in the ocean based on percentages of mass, so just sheer amount of living material, about 95% of the life in the ocean is up near the surface, and very specifically right along the continents.
Mhm.
And so when we're at the beach or when we're boating or you're going on a whale watch, you are looking at this very, very narrow band of highly concentrated life. And it's a lot of which is big enough that we can see it if we're looking for it. So dolphins and seals and different kinds of fish and birds that are diving and those kinds of things. It's hard to think about everything else and all of the space. And even though there's maybe not that many creatures per square mile or per square kilometer, there's just so many of those square kilometers or those square miles that it adds up to a lot of creatures. And that it's tough. It's hard to start to wrap your brain around. I also show a lot of information, depending on the semester, on fishing catches and looking at just how many tons of a certain kind of fish are being caught within a given year. And when you start to look at those numbers, I also feel like that maybe starts to put things into perspective a little bit, that yes, there are amazing numbers of creatures in different parts of the ocean, but if we are catching them faster than they can replace themselves, we're going to start to see a big change in that number. And we can already see it in certain species of fish, like certain types of tuna, as I'm sure a lot of people know. The numbers are just crashing because they've been overfished for decades.
I'm sure people in New England are very aware of how fishing and the catches that people are allowed to do and the number of boats and so on can go out
Yes,
and do fishing, because there have been so many restrictions because fish are just disappearing and they don't want them to go extinct.
exactly.
Conflict with people making a living as fishermen. Um, the book that wanted to say brings up so many of these environmental causes. I'm wondering, what can students do? You know, a lot of students are in school, they're busy, they want to be educated about what the issues are, but what can they do about some of these environmental issues or help the oceans or what have you? What are some of the things that people can work toward?
Oh, I love that question too. Um, I mean, I think sometimes, especially as students, um, you underestimate your own power. And especially for students at Berklee, you have this amazing platform of music that you can use to communicate to other people. And so one of the things I really try to encourage all of my students to do is, if you hear something, whether it's in class or whether it's something on a social media post about the ocean or about a land-based area or ecosystem, write down how you feel, and why not include that in some of your music, whether it's the lyrics or whether it's just the power of the music to make people feel. I think that can really make an impact. Especially when you look back at the history of music and how it's been used to rally people for a number of different social causes, especially environmental causes.
Oh yeah, I mean, music and the power of music to make people feel the emotional and to create cultural change.
Yes.
And this is, I mean, environmentalism is going to have to create massive cultural change in a very short period of time, if we're to stay within our lovely earth and have it keep it green,
Yes.
or the
Yes.
keep them blue.
Yeah.
um,
Exactly.
um, to continue to provide a wonderful world for all of us. And so many millions and billions of people on Earth are going to be affected by that in short order. And I know that a lot of people have concerns, or they don't know, what can I do? And it's so overwhelming. But I think that actually artists, you are the answer, because
Yes.
you
Oh,
have the
here,
power
here.
to move people emotionally to make those cultural changes, which is what really is necessary. It's
Oh,
not just
yes.
economic change or political change. It's really a cultural way of thinking. It's, way of thinking about the world that is required, I guess, of us. I mean, we're all going to have to do that. And that's a big shift.
It is a big shift. And I think when it's that big of a shift, it's scary to start thinking about how are you going to move towards that goal. And I completely agree with you. I really feel that artists are the leaders for getting us to start taking those steps.
I agree. And so, this is a really great book for students to read and get that basic grounding, basic understanding, even if they're, not specifically in an oceanography class, but want to know, here's some basics that you can have, and you get a lot of information. It's chock full of modern data,
Yes.
right up to the minute. It's a new book, and it's easy to read, and I
Yep.
can tell you that because because I read it. And it's not onerous reading, and we have it as an electronic book in the library, so you can start it and stop it anywhere you want. You can search through it. You can see the pictures, which I did, which are pretty fascinating.
Oh, that's my favorite
Weird
part.
things to look at. um, so it's really actually pretty enjoyable for a beginner.
Yep.
I would highly recommend that. So I really do appreciate you talking to us about this book today. It's just a wonderful way to get started in this area of learning more about the oceans.
Oh, I am absolutely delighted that you enjoyed the book. And I really hope that some of the students will take advantage of the electronic copy. And I agree with you. I thought it was super easy to read. I wasn't reading it for sort of the science part of it. I just was enjoying reading it. And I also, usually when I read a book, I try to read like the whole thing from start to finish. For some reason, I was jumping around in this book, and it was easy to do it that way, to read the chapters out of order. So if one of the chapters sort of takes your fancy, I would start with that one.
Well, I'm glad you mentioned that, because I also thought that she's so organized for someone who doesn't know a lot of the jargon, which me, if you have to start from scratch, you can start with chapter 1. But if you want to know about the issues, you can go to the end of the book and just read about the issues.
Exactly.
Go back later and fill in about finding out about the special worms and all the creatures of the deep.
Exactly.
And one of the last comments I made was that one of the things that struck me about the ocean is that nothing goes to waste.
Nothing.
Talk about recycling and talk about using every last resource. The creatures of the deep are the ultimate recyclers.
Yes. Oh, that is a perfect.
You're environmental specialists.
Yes. Yes.
Because there's like nothing goes past them. And so I was like really struck by that maybe we could at least learn that one lesson. That
I think that's brilliant. Yes.
With our resources. Anyway, this has been really a delight, and thank you so much for speaking with us today. And
it is my pleasure. Thank you so much.
That's great. Thank you.